In this particular video, we would be looking towards the differential rule and we would be speaking about quotient rule. So this you have seen earlier videos where we have spoken about different other rules. So this part we would be speaking particularly about quotient rule. So I would be showing you the basic formula behind this, and we will be solving few examples of quotient rule. So if we get a kind of a function, let me show you an example. So it would be f of x divided by g of x. Then the basic rule for quotient would be g of x multiplied by f prime of x. So we are using this prime notation, otherwise using the Leibniz notation for dy by dx would be too long, minus f of x. Similarly, you can just swap, it would be g prime of x, and this would be whole divided by g, we would take this term x squared. So this is what is the quotient rule talks all about. Now just note one thing, that if you are swapping in between these terms, that is absolutely fine. Like you can take f of x dot g prime of x, this part, and you can swap gx of f prime of x into the other part. But just remember, you cannot do this way. Like you cannot swap between g prime of x and f prime of x, and you can make gx or fx onto the other side. So the swapping would be done, but this g prime of x and fx can be swapped in between, but not with these parts. So let me just cite an example of how things would work out. So if we get a kind of a function like f of x, and this would be equal to x squared plus 3x whole divided by x plus 4. Say for example, we would like to differentiate using the quotient rule. So in this case, what I will do is that I will use the term d by dx, right? Because we have been discussing with that. So if I take the d by dx of this, then this would be this would be x plus 4, which would be the first term. So what we do is that we can write, so here you see that g of x is x plus 4. So automatically this would be written as x plus 4, and I put a brace in order to give you a better understanding, and I write d by dx. And then what I do is that I take f, so f prime of x would be the numerator. So just mark those things, x squared plus 3x, right? And then we put this minus sign, so we get a minus sign over here, right? Then again the fx, so we are not differentiating, we're just putting this term, so it would be x squared plus 3x, right? And then we have to differentiate the gx. What is the gx? This would be x plus 4. So I would write this as dot d by dx of x plus 4. And I have to put a line, and this would be g of x prime squared. What is g of x? This one. So I can put x plus 4 whole squared. Okay, so what we are doing is that we are solving out for the d by dx. I hope it is visible. Yeah, it's now. So what I can write here is that therefore d by dx equals to, so I'm just solving this out. So how would I solve? So I can write x plus 4, right? And then I can write this part. Let me see. Yeah, so what we can do is that we can solve this out. So we will take, we have learned this, we will differentiate this term, that is x squared plus 2x. So this would come below, so it would be 2x. I'm not showing this because you have already done this. If you have not, you can just look into my other video. So just to keep you a notes that we are solving this, and if I just do it over here, so if I put a d by dx, it would be as you know 2x, and plus 3 and x would be 1. So what we are doing is that we are from here x squared plus 3x, what I'm doing is that I'm bringing this down as 2x and then 2 minus 1 on the top plus 3 and the vanishing factor x, because it is the differentiation of x is 1. So what I get over here is x plus 4, this one, and then by differentiating what I get is 2x plus 3, right? You can omit this part, this is just a scribbling, minus what I can do, I can differentiate this part, so it would be x squared plus 3x, sorry, this part, so it would be just as x squared plus 3x, and d by dx of x plus 4 would be, this would be 1 and this would be running to 0, so it would be 1, right? And then I have to put this line because it would be x plus 4 whole squared, right? So proceeding further, what I can do is that I can open this one. So it would be 2x squared plus 3x plus 8x plus 4, 3, 12, right? And then it would be x squared minus 3x. And I'm keeping this term, oh, I'm so sorry, oops, I need to write it once more for you. So this part you can omit. So let me write it. It would be 2x squared plus 3x plus 8x plus 12 minus x squared minus 3x. I'm keeping for a definite reason this part I can keep it just as it is, so I can just write it as x plus 4 whole squared. Now further solving, what it would give is that I can, so this 2x squared and this x squared gets, you know, not cancelled out, but it would be x squared, right? Right, and this 3x and 3x would get cancelled out, and then we are just left with x 8x plus 12, right, and whole divided by x plus 4 whole squared. So this more or less gives you the answer. If you can further factorize and you want to solve it further, however you can do that. So this is how we are solving the quotient rule. So just to keep it a note that in case of a quotient rule, what we need to do is that we have to first, as usual, write the fx, I would say, yeah, which one is f of x and which one is g prime of gx, and then we need to differentiate. So let us see just for another example so that things becomes clearer. So what if I want to take a, what if I want to take a, say for example, d by dx of this factor, this is 7x plus 4 whole divided by x squared plus 5. So what if you want to solve this particular expression? So in this case, what I can do is that I can write f of x equals to 7x plus 4, and let me write g of x equals to x squared plus 5, that is the denominator. Now what I can also write is that if I take a differentiation factor of this particular part, that means if I can write f prime of x, and then how much it would be? It would be 7, because these are constants, so it would reduce to 7, right? And if I take the differentiation factor of gx, that is g prime of x, how much it would be? It would be equal to 2x, x minus 2, and this is constant, so it would become 0. So solving further, what we get is that, let me write the formula once more so that the things become pretty clear. So I can write g of x minus f of x, g of x dot f prime of x minus f of x and dot g prime of x, and this would be whole divided by g of x squared. So this is the formula of the quotient rule. So we can just substitute those values quickly and it will be easier for you. X squared plus 5 dot f prime of x we have already differentiated. So I think that better to differentiate earlier and then put the values, it becomes clear. Minus 7x plus 4 of 2 and multiplied by 2x. So, and this time I would be careful. So it would be the denominator. So it would be x squared plus 5 whole squared, right? Now if we can open this term, how much it would be? It would be 7x squared plus 35. This one would be minus 14x and this would be minus 8x, right? And we can put the numerator as x squared plus 5 whole squared, right? So that is how it is. So 7x squared and this 14, this would be 14x squared. I'm so sorry for this. X squared plus 5 minus 7x minus 4. So it would be 35 minus, this would be 14x squared, right? So what we can see is that this part and this part we can compute, and what we get is minus 7x squared, and this would be minus 8x, and this would be plus 35, right? And this would be whole divided by x squared plus 5 whole squared. So if you further want to solve for the factors denominator, you can solve it, but this is more or less gives us the quotient rule, the differentiation factor. So what this would be a last and quite a simple example of quotient rule. So let us see if we get a kind of an expression like this, where we get d by dx and we want to solve out for x squared whole divided by x minus 5. So this would be the factor which we are trying to solve things out. So we can definitely write from here that f of x would be x squared, right? And g of x would be x minus 5, the denominator. From here, if we differentiate f prime of x, we get 2x. And from x minus 5, if we take the g prime of x, it would be how much? 1. Because this would be 1 and this is a constant. So again, we will follow the same rule so that the mistakes, etc. are less. So we write gx of f prime of x minus fx dot g prime of x, and this is whole divided by g of x squared, which is our quotient formula, and we will just substitute these values. So we get x minus 5 dot this one is 2x, so this would be 2x, and this would be x squared product dot 1, and this would lie as it is. The denominator would be x minus 5 whole squared. So we can just solve things out, and this would result into how much? This would be 2x squared minus 10x, and this would be x squared. So we can omit this part. This is not required. And then we can write the x minus 5 whole squared. We can leave as it is, right? Or we can further solve it. So this one, this and this gets computed. So it would be x squared minus 10x. And this would be, as usual, x minus 5 whole squared, right? So we can take x common over here, and we can write it as x minus 10. And we can leave it, the denominator part, x minus 5 whole squared. So these are few examples which would help you to solve further complicated problems regarding quotient rule. So this is how you do it. Just before we wrap up, I would just like to show a quick tip. So if I'm making the d by dx of f of x, and you're writing this f prime, g prime, and x squared, you can use it in a kind of a different way. So you can write it as d by dx high divided by low. High is the numerator, low. And you can just, in the same way, you can write this expression as d by dx of high minus high d by dx low, low, low. That means the squared. So you will find similar kind of examples over the internet, or some other formulas where we are trying to give a kind of a easy interpretation so that you can remember which of the terms. So d by dx high low equals to d by dx high minus high d by dx low divided by low, low. So that is all that, that brings us to the end of the quotient rule. So I think things have been clear, and you have understood all those parts. So you can further solve examples, and maybe I would like to make a video on difficult problems of differentiation. But as you know that I'm working intensely on the Einstein field equations, which is my next agenda for a series of videos, and you can have a look onto that. Before we wrap up, also for this d by dx part, although I have mentioned earlier, but it is worth mentioning, if you want you can have a look into the d by dx differentiation rule, why d by dx and dy by dx is different. So here is a nice kind of a summary which I have made. D by dx with respect to x and dy by dx is basically a kind of a command, and here I have laid down few rules which you will be able to understand. You can look into my difference between series videos, where this is the second one. And in summary, what I can tell you is that d by dx is a kind of a verb which actually tells you as an operator what to do, and dy by dx is a noun. That means it is a statement which is already happened. So I hope you like this part, and this is a kind of a quick, easy recon kind of a thing. So just subscribe, like, and if you want you can share my channel. We'll coming up with more serious and complex topics on mathematics and physics. Hope you like it. Thank you very much, and wish you all the best, and wish you a very happy new year and a Merry Christmas. Thank you. Bye.